Hey, AP Chemistry peeps. So part of your assignment was to go over this Beer-Lambert law, absorbance versus concentration lab. And I'm going to go through a few parts just to uh, make sure that we're clear on what you need to do because some of the questions are open-ended. And it would be great if we went over this in class. Time is kind of crunched right now. So I'm going to just skim through parts. Part one, when you did this part, they took the cuvette and passed it through different colored lights from blue to red, and you were to see kind of how absorbance was changed as you went through them. And so you can measure out the absorbance using these tools that were on up here at the top. And you get these little holes that you drag around. But the real part comes down here in number 4 when you have this 0.5 molar solution of cobalt chloride. Make sure that you choose that over here, cobalt chloride, 0.5 molar. And when you do that, make sure that it's lined up with the blue light, because that's what it asked for. And you're taking this and kind of moving along. And so you're looking at where you place it over that little circle, and it blends in really well. You notice that you can still see that circle when I put it over these holes because those aren't matching the color. The more I move it over this way, the more it tends to blend in. It tends to blend in best around 44 or 42. It's kind of like between those two, it's almost a horse apiece where you can barely see it or it blends in really well. But something like 40, yeah, you can really tell that those colors are different. And something like 49, no, those are really different too. So that's kind of what you're doing there. So like 44 or 42, that's fine. And you'll find that some of your measurements, you might not have them exact, and that's okay. That's okay. But that's either 44 or 42. That's fine. So that's part one. Part two, transmittance versus wavelength. You're really looking at those different colored lights, and they have different wavelengths of light, but you're really looking at how that light is absorbed through the different solutions. So it asks you to come up with a way of doing that. It's really, you switch your solutions, and you want to have a high concentration of each solution. You'll notice that when you do copper sulfate, you won't be able to load it for the highest concentration, 0.5 molar. Just do 0.4 molar, and that's fine. So you want to use the highest concentration possible for each. So when you do the copper sulfate and you let it run through that video, you're looking to see which of these colors actually absorbs the most. And you'll notice that when you started off going through some of these, that it really didn't change the light. But once you get through to the later ones, it starts to get a little bit more shaded. And that's because light is being absorbed for the copper sulfate more by the red colored wavelength. And so that's that part. And then for the cobalt chloride, we can do the 0.5 molar. You'll notice that cobalt chloride, the color for the solution is red, and it's the blue LED that really absorbs light and not so much the red side. And so you do have some things that will absorb a little bit, like you have this aqua colored one that also absorbs. Notice that it's shaded, and but probably the blue one, that's probably a deeper color. So that's really all that you do for that, and that's what you tell in number 4. For the cobalt chloride, it's the blue LED. For the copper chloride, it's the red LED. For part 3, you're going to need that information in order to do this part. You're going to figure out the absorbance from those LEDs for different concentrated solutions. And you're going to kind of do a little experiment here. Down here at the table, I'll kind of tell you what you need to do. So you need the concentration of one of the solutions and just choose one of them. So if you want to do copper sulfate, that's awesome. And the units, it's molar, variable. You could just have concentration of copper sulfate. Awesome. But then you're going to measure the transmittance. I think I'm spelling that right. Right? Yeah. And units, no units for it. But you are going to need to add an extra column here. So you're going to insert column to the right, and we're going to calculate the absorbance. And what we're going to do is go through different concentrations. You could do the 0.4 molar, 0.4 molar of the copper sulfate, and 0.35, 0.3, 0.25, 0.2, and insert row below. And they have all these different concentrations. 0.15, insert row below, 0.1, insert row below, 0.05, and you want to have a 0 mark. You want to have a blank one where it has no copper 2 chloride in it. So what you do is you go through that for all the different concentrations for copper 2 sulfate. But you remember that from the part above, for copper 2 sulfate, it was the red LED that absorbed the light the most. And so that is the LED that you need to use every time when you measure the absorbance here. So you go along and you get it to the red LED and you stop there. And you go up to the tools and you measure the absorbance. So here we'll try it out. And 42, 4, well, let's see, 42, 44, oh, 44 looks pretty good. So you want to find an absorbance where it kind of really blends in again. So like 43 or 44, those tend to look really good. I'm going to say 44 for this one. So in the transmittance, remember that these are percents, but for transmittance, you write out the percent as a decimal. So it's 44%, it's 0.44. And then you go to your next concentration, and you're going to repeat that. So go to the 0.35 molar, and you run the video here, but you have to run it till it gets to the red LED. And when it gets to the red LED, that's when we pause and we look for the percent transmittance. You'll notice that this changes a little bit. So I'm going to try to find the one that matches it the most. And it looks like 45 really works. So that really blends in. So we got 0.44 for the first one. Now I got 0.45. You're going to keep doing this for each concentration until you get down to 0. And that'll be that part. Then once you get all of those transmittances, you're going to calculate the absorbance. And that they showed you the equation for. This you just enter on your calculator. So for the absorbance here, it's equal to the negative log of the transmittance. This is not an equation that you need to use on the test. This is really just kind of finding the relationship that we are going to be using. Right? But when we calculate the absorbance, again, use this equation, negative log of transmittance. So on your calculator, you type in, it's equal the absorbance here is equal to the negative log of 0.44. So if I type that on my calculator, oh goodness, and I get 0.36 if you round up. And that's fine. If I do this one, 45, and log, I get 0.35, 0.35 if I round up. And so you're going to be doing this as you go. And and you're going to do that all the way down until you have the concentration of 0. When you do this part, you have to keep the same substance. You're going to be changing the concentration, and you need to look through the same LED. So each time you do this, for copper sulfate, you have to look through the red LED. If you choose to do the cobalt chloride, like let's say you just wanted to do that, that is fine. It is a free country. You can do that. You just need to make sure that you use the blue LED for cobalt 2 chloride because that's the one that absorbs the most. Okay? So just things to keep in mind. When you're done with that, you're going to create a graph. And that graph looks exactly like this. You're going to change the y-axis to absorbance, the absorbances that we calculated. And there's no units for absorbance. Don't worry about it. And then for the horizontal axis, we're going to have it as the concentration of your substance. And you'll notice that there are a few data points that were already plotted for me. So it will plot it automatically for you. When you're in here, make sure you do not click this uncertainty thing. Just leave it as no uncertainty. But you're going to plot it out. And that's going to be the important part that you need. And so make sure you complete the data table. And then you make sure that you set up the X and Y axis on here. And again, they're just drop-down menus. And you'll kind of tell a little bit about your graph. But then the last part is a mystery solution. So if you do the mystery solution, you need to choose, it's either copper sulfate or cobalt chloride. Use the one that you kind of did the test for. And you need to test out these mystery solutions and see if you can determine what the concentration is based on your graph. And it's really just reading a graph. Because if you can figure out the new absorbance, you can actually figure out the new concentration and line it up on the graph. That's really how Beer's Lambert law works, and that's how we use it. So if you ever have any questions on the rest of the lab, feel free to email your instructor, but make sure that after you find your test out and figure out what the concentration is of that mystery solution, check your answer in part 5, and then you'll be all set. We'll discuss this next class period. All right, we'll see you guys. Have a great day.